Okay, this is my second take 2 video, and it's from chapter 7, problem number 119 and problem number 125. So again, the reason why everything is in here is that I'm recording it twice because the first ones were unclear. Okay, so in here it says that for 119, it says that Ko is the empirical formula for either potassium 2 oxide or potassium peroxide. Okay, and they want to know which one we could be talking about. Now, if it's potassium 2, that would make it K2 plus and oxide 2 minus for Ko. Okay, let's look at why this does not work. And so what we do is we look in the periodic table and we see potassium right here. Potassium only has one valence electron, which means that its first ionization energy is quite low, and it will lose that electron quite easily. But then it's going to have a configuration that looks exactly like argon. Oh yikes, it is not going to want to lose an electron from here because that second ionization energy would be very, very high, which means the potassium is just flat out not going to want to be K2 plus. Because it only has one valence electron, it's going to want to be K plus. So in order for something to have an empirical formula of Ko, then we also need an O1 minus. And O1 minus is really a peroxide, which is two of them, O2, 2 minus, with 1 minus charge on each oxygen. So that would mean that we would need 2 K plus and 1 of the O2 2 minus ions, and this would balance each other out to K2O2 with an empirical formula of Ko. Okay, now if we come down and we look at 125, 125 wants us to look at an equation where we mix lithium and nitrogen gas to form lithium nitride. And they want us to balance this. So we know that lithium, because it is an alkali metal, will lose 1 valence electron to become 1 plus. And that nitrogen, because if it gains 3 electrons, it'll look like neon, will become nitride and 3 minus. So that means that we'll need 3 lithiums, 3 positive charges to balance out 3 negative charges. So we have Li3N, lithium nitride. And in order to balance these out, because this is N2 gas, remember nitrogen gas is always diatomic, we need 2 of these, so we need 6 lithiums. Right, now let's look at B. We have rubidium plus sulfur to form rubidium sulfide. Okay, now rubidium is also an alkali metal, which means that it will form a 1 plus charge because it only has 1 valence electron to lose. And sulfur will become sulfide, which is an S2 minus, because if it gains 2 electrons, it looks like argon. Right? Then we'll need 2 of these rubidium ions to balance out the 2 minus charge here. So we make rubidium sulfide, Rb2s.